Alright, so question 1. Work out 1 over 7 times 2 over 3. So remember from fractions, when you're multiplying, you just simply multiply across. So we've got 1 times 2 is 2, and 7 times 3 is 21. And that's our mark there. Work out 3/5, take away 1/3. So adding or subtracting fractions is where you need to have the same denominator. So we need to find the lowest common multiple. So for 5 and 3, it will be 15. So we're going to have a fraction like so. So both over 15. Then we need to look at this and think, okay, what do we have to times 5 by to get to 15? Well, that's times 3. So don't forget to write this top and bottom. Okay, it's very easy to do it quick and then make a mistake. So then we look at the numerators. 3 times 3 will give us 9, and of course 3 times 5 will give us the 15 that we already have here. Then we do the same here. So then we look at 3, and what do we times that by to get to 15? Well, that was times 5 times 5. So therefore we do 1 times 5, which is 5, and of course 3 times 5 is 15. Once we've got them to the same base, as you can see here, we can then just do 9 take away 5, which is 4. So we end up with 4 over 15. Right, okay, with question 2. Competition of prizes won every 2014 seconds. Work out an estimate, okay, so this being the keyword, for the number of prizes won in 24 hours. You must show your working. So one easy way to visualize this is if we say prizes won, something along the terms of something nice and easy, one prize every 60 seconds. Okay, so let's just ignore that question for now and just break it down into a basic example. So one prize every 60 seconds would therefore mean that's the same thing as saying is one prize per minute. Okay, and then of course if you've got one prize per minute, that would lead us to 60 prizes per hour. Okay, and so on. So the keyword, like I just mentioned, was estimate. So we need to do some rounding. So make the numbers that we've currently got easier to handle. So 2014 seconds will go to 2000 seconds, and 24 hours will go to 20 hours. Now, as with anything, we need to have like with like, so like units with like units. So we need to do some converting. So the first thing I'm going to do is I'm going to convert the 20 hours into seconds. So how can I do that? Well, in 1 minute there are 60 seconds. Okay, and in 1 hour there are 60 minutes. So in order for me to find out how many seconds there are in an hour, I need to do 60 times 60. Then we know that 6 times 6 is 36, and don't forget the 2 zeros. So we've got in 1 hour there are 3,600 seconds. Okay, so 1 hour is 3,600 seconds. Now we rounded the 24 hours to 20, so if I need to find out how many seconds are in 20 hours, well, from this point of view I'm going to times by 20, so I need to times this number here by 20. So I'm going to have 3,600 times by 20, and of course we can do 36 times 2, which is 72, let's not forget the zeros. So I've got 72,000 seconds in those 20 hours that we're talking about. Now, it says that for every 2,000 seconds, or every 2014, one prize is won. So we've rounded that to 2,000. So basically, we need to find how many 2,000s will go into 72,000. So if we bring that calculation here now, if I was to write that, we're going to have 72,000 divided by 2,000. Well, we can get rid of the zeros like so. We end up with 72 over 2, which is 36. So therefore, in 72,000 seconds, we end up with having an estimate of 36 prizes. Okay, question 3. So we've got this question here with parallel lines. You can see that this question is out of 4 marks. We need to work out this value of this x down here. So what we can do is we can start off by looking at what we've got. We should be thinking, as soon as we've seen parallel lines of alternate corresponding angles, co-interior angles, and of course angles in a triangle, or at least the sum of that. So by me looking at this, the first thing I can spot is this angle here. So what we've got is corresponding angles, or backwards f. So from what I can see here, this would mean that this angle here is 60 degrees. So I can say that DEQ equals 60 degrees, and that is due to corresponding angles. Okay, so that's my first point. My second point would be that if DEQ, so the angle we just found, is 60 degrees, I could then, on top of that, find the Z angle, which is of course not the Z angle, it's the alternate angle. So then I could say that angle EQR is also 60 degrees, and that's because of alternate angles. So now what I've got is a 60 degrees written here, which leads me to my third point with a triangle. We know that angle sum in a triangle is 180 degrees, so therefore angle QRE will equal, okay, so now we've got 180, take away 60, take away 80, and in brackets here we can put angle sum in triangle is 180, and of course if we do this here, 180 take away 80 will give us 100, and 100 take away 60 will of course give us 40 degrees. Therefore x equals 40. Okay, question 4. Here's a rectangle with width 2 centimeters and length 8 centimeters. A-sided shape below is made from 4 of these rectangles and 4 congruent right angled triangles. Okay, so we need to work out the perimeter. So perimeter is where you add. So we find the distance around the shape. So distance around the shape. So what we can do is we can start filling this in. So we know that the width is 2. So if I fill 2, 2, 2, and 2, we know that the width here is 8. Or just make that be easier. See, let's do this one here, 8, 8, 8, and 8. Okay, now we need to find these lengths here. Okay, so in order to do so, we need to think, okay, so if this entire length here is 8, we've then got this section right here, which is worth 2, which would mean that the section that we're missing is worth 6. So this would be 6. Okay, and it might be better if I showed that on different parts. So let's look at this section here. Okay, so if I know that this entire section here is worth 8, I know that this here is worth 2. Well, that could only mean that this part here is worth 6. So if I extract one of the triangles, it did say that they are 4 congruent, so they're all the same. If I extract one of them, I've got 6 here, 8 here. I need to find this side here. Okay, now if I look, it also mentions, but if I look, this is a right angle triangle, so right angle triangle. In order to find this side, so the hypotenuse, because that's opposite, we can use Pythagoras. So a squared plus b squared equals c squared, and I can fill that in. So c squared being the hypotenuse, I don't have to do any rearranging, so I can just substitute the values in. So that will be 6 squared plus 8 squared equals c squared. Now just be very careful, make sure you fully list the flow of your working out. So just write 6 squared, which is 36, plus 64 equals c squared. That of course adds up to 100. Okay, and then we need c by itself, so to get rid of that square, you square root. So square root of 100 equals c. Therefore, c equals 10. Okay, so if we now fill that in, so if I just get rid of that, if I now fill that in, we've got 10, 10, 10, and 10, and I can just start my perimeter. So let's say I start here and I go up. I've got p equals 2 plus 10 plus 2 plus 10 plus 2. I'm here at the moment. Plus 10 plus 2 plus 10. Or of course you've got the quicker way, but you could just say p equals, we've got 4 times 2. And then we've also got 4 times 10. So 4 lots of 2 and 4 lots of 10. Well, that's going to be 8 and 40. So therefore total perimeter is 48 centimeters. Okay, with question 5, this type of question has come up quite a bit in the practice papers, so you can have a look at it there, but I'll go over it anyway, just very quickly. We got Fullbeck to Gambia is 10 miles, Gambia to Halton is 18 miles. Raksha is going to drive from Fullbeck to Gambia, then she will drive from Gambia to Halton. Rashka leaves Fullbeck at 10 o'clock. She drives from Fullbeck to Gambia at an average speed of 40 miles per hour. Raksha wants to get to Halton at 10:35. Work out the average speed she must drive. So, broken into segments, we're going to go with, this is segment 1 and segment 2. So I'm going to say F to G. Okay, now we've got things like speed, distance, and time being asked, or at least speed, time is mentioned, and we've got a distance mentioned here. So we need to know the formula, which is of course speed equals distance over time. Now I know some of you use that triangle. If you want to use that, that's absolutely fine. I'm going to stick with the formula. So F to G, let's see, what do we have? Let's write speed, distance, and time, and fill in what we know. So we know that we've got a distance of 10 miles. And then do we have a leaving time? No, but we do know that she leaves at 10 o'clock. Okay. But we do get a speed, so F to G at 40 miles per hour. Okay. Then if we look at the next segment, so 1 and 2, then we've got G to H, speed, distance, and time. What do we have? We've got a distance of 18 miles. And then do we have a time or a speed? No, but what we do have is the time that she would like to get there. So we've got 10:35. So basically the entire journey, if I label that as 3, needs to take 35 minutes. So if we find out F to G, how long that took, maybe we can go from there. So we've got speed equals distance over time. We need to find time. So I'm going to times by t. So I'm going to end up with TS equals D. And then I need to get rid of the S, so I'm going to divide by it. So T equals D over S. Now if I fill this in, I'm going to have T equals a distance 10 over 40. Now like we did before, we can either do long division or we can cancel out the zeros. And you'll see that T represents 1/4. So if you're not sure what units, think about what distance we used. So distance was miles, and this is hour, okay, or miles per hour I should say. Okay, and then they would cancel out to give us a T of 1/4 of an hour. So if we convert that into minutes, because we are dealing with minutes up here, a quarter of an hour, well, a quarter of 60 would be 15 minutes. So the journey F to G, or the first section, takes 15 minutes. So if that takes 15 minutes, okay, and the whole thing has to take 35, then if we do 35 take away 15, that's going to give us 20 minutes. Okay, and then we can use this information here to place here, so 20 minutes. So the question's asking what's the average speed from Gamby to Halton. So if speed equals distance over time, we have speed equals 18 over 20. And now before we do this calculation, this is the bit where we can't be caught out. We need our answer in miles per hour, so we've got our miles sorted, which is here, but this is minutes, so we need to change 20 minutes into hours. So 20 out of 60, well, as a fraction that would be 1/3. So what we end up with is speed equals 18 over 1/3. If you remember dividing fractions, we'll end up with speed equals 18 times 3 over 1, which is then of course 54. So then we end up with a speed of 54 miles per hour. Okay, with question 6, Adam, Ben and Charlie share some money. Adam gets 1.5 times as much as Ben, Ben gets 3 times as much as Charlie. If they shared £68 in total, how much does Charlie have? So reading that question, we know we're dealing with the ratio. It's a distribution of £68 and in a certain ratio. So we've got Adam and Ben mentioned in this first part here. So Adam gets 1.5 times as much as Ben, so that would mean that if Ben got 1, Adam would get 1.5. Okay, then our second ratio is this one here. Ben gets 3 times as much as Charlie. So if Ben is here and Charlie is here, if Charlie got 1, Ben would get 3. So we've got two ratio setups here, and what we need to do is combine them because all three of them share the £68. So what we need to have is A to B to C. So if we're looking at that, we need to look at what numbers to find the lowest common multiple between any of the numbers to make them merge. So by looking at this question, you can see that there are two sets of B's. So it means we need to somehow merge these two numbers. So the way we can do that is by making the numbers the same. So what I'm going to do is I'm going to keep the B to C, the Ben to Charlie, as 3 to 1. And I'm going to try and get this one on the left, the Ben's part, up to 3. So if I do 1 times 3, I'll show that here, that's going to give us me 3. If I do 1.5 times 3, well, that's going to give me 4.5. So I'm going to end up with, if I just get rid of that here, I'm going to end up with 4.5 to 3 to 1. So that's, remember, the right hand side here, and then I've merged this with the 3 here. So I've got 4.5 to 3 to 1. Now what we need is a whole number. So how can I get 4.5 to a whole number? Well, if I times that by 2, I'll get 9. So I'm going to end up with 9 to 6 to 2. So now I have my ratio. They share £68. How many parts are there? Well, we do 9 plus 6 plus 2. So we get a total of 17. And now we need to find the value of 1 part. So 68 divided by 17 gives us an answer of £4. So then we're working with £4 per part. And then we need to work out how much Charlie has. So if we look at our ratio, he will get 4 times 2 because he has 2 parts. Therefore, a total of £8. Right, prove that the sum of the squares of 2 consecutive odd numbers is always 2 more than a multiple of 8. So for my first odd number, I'm going to say that it's 2n plus 1. Now the reason I'm saying it's that is because anything times by 2 is an even. If I add 1 to it, it will make it an odd number. So odd, make it an odd, okay? So it does say 2 consecutive odd numbers, so if this is my first one, my second odd number will be 2n plus 3. Again, an even plus an odd will give me an odd number. So that's our 2 odd numbers sorted algebraically. It then does say the sum of the squares. So I'm going to write 2n plus 1 plus, because we're talking sum, 2n plus 3. And it does say of the squares, which means that each of these are squared. So if I then expand that out, I've got 2n plus 1, 2n plus 1, plus 2n plus 3, 2n plus 3. So then again, if I use FOIL now, 4n squared plus 2n plus 2n plus 1 plus 4n squared plus 6n plus 6n plus 9. If I collect my like terms now, so I end up with 4n squared plus 4n plus 1 plus 4n squared plus 12n plus 9. Going again, now I can look at the broader picture, so then I end up with 8n squared plus 16n plus 10. Okay, so I've ended up with that stage right now. And this is the part where I look at the question, because it does say is always 2 more than a multiple of 8. Well, if I'm looking at these numbers here, I can see that I can pull a multiple of 8 out of, but this one looks to be an issue. Now, it does say 2 more, so if I'm to get this quadratic that we've set up here, 8n squared plus 16n plus 10, it does say 2 more. Yeah, 2 more, so that means whatever value you get, add 2 to it, and that's what the number we're talking about. So if I was to then split this up into 8n squared plus 16n plus 8 plus 2, we've now sorted our plus 2 more part. If we look at the beginning part, where it says, or the later part, that multiple of 8, I can now see that I can pull out a multiple of 8 for each 3 terms. So now what I can do is write 8, open bracket, n squared plus 2n plus 1 plus 2. Then we have this section here, which is responsible for the multiple of 8, okay, because it's going to be 8 times whatever's inside, and then the 2 more part, which is obviously this section here, and that's for your 3 marks. Okay, so with question 8 here, we've got information taken by 100 people in a fun run. Please remember that cumulative frequency is where you add up. So we're going to do 4. We start off at 4 because that's where we are here. Then we do 4 plus the 16, which gives us 20. And then we add the following number, 36, which gives us 56. And then we add on the 24, which gives us 80. Then we add on the 14, which gives us 94. And then 94 add 6 gives us the 100. This part right here, make sure it adds up to the 100 initially. If it doesn't, then you've made an error somewhere. You need to check back because it should add up to 100. So for 2 marks, on the grid, draw a cumulative frequency graph for your table. Okay, so plotting these values, I should have value here is 10. Therefore, these are going up in 2s. So for my first plot, it should be here. Okay, and then I should have 40 at 20, 50 at 56, 60 at 80, 70 at 94, and then 80 at 100. So once I've done that, I can then connect this up. So you do not want to join up with a straight line. It needs to be curves. So you should end up with something like that. Now it says here, use your graph to find an estimate for the median time. So if we have a total of 100, the median of that will be half of it, which is of course 50. So we're talking about number of people, which is on the y-axis. Therefore we look for the number 50, which is here. We go across then and leave this working on your graph itself, and we go down and we should get a value of around 48, 49. Obviously if you're using a ruler, you could be a lot more accurate, but for me it's coming out as around 48, 49. Then part D, use your graph to find an estimate for the number of people who took longer than 63 minutes. So finding 63 minutes this time on the x-axis, we've got 61, 2, 3. I go up with as straight a line as possible. And then across here you find a value of 84. Now that does not mean that the answer is 84. Okay, we know that in total it's out of 100, and we've just got a reading of 84. We're interested in this section, so how many people are here? So we need our 100, take away the 84, which will give us a total of 16. Okay, with the factorizing, we start off with the numbers first. So the highest common factor of 12 and 24, that's going to be 12. Then we've got our x and y, so we look, we've got 1x and an x squared, so the highest therefore we can pull out as an x. Then we've got a y squared and a y, highest therefore we can pull out as a y. Once we can't pull out any more, we then open up a bracket. We then think, okay, 12xy, what would we have to times that by to give us 24x squared, y squared? Well, if we write a 2 here, doing all of that will give us 24xy, but we need x squared, y squared. So that means we're going to have to add an x and a y to that. And then you need to ask yourself, what do I need to times 12xy by to get 12xy? Well, it's just going to be plus 1. Okay, so quick tip, start with the numbers first and work your way through. The highest either letter or number you can pull out, it obviously can't be higher than the lowest one. Next up, we've got factorize EF minus 4E plus 3F minus 12. Okay, so if we look at factoring the first section, we can then pull out E. So we have E open bracket F minus 4. Then we have plus 3F minus 12. If we then look at pulling out a highest common factor, if I write E, F minus 4 again, we then can pull out highest common factor of 3. So I can write plus 3 F minus 4. And you can see that I've got two sets of F minus 4. So it's a bit like when we're factorizing a quadratic. We can now rewrite E plus 3 as one of the brackets and F minus 4 as the other factorized bracket. Part C, factorize x squared minus 16. This is difference of squares. So you know that because of the minus, followed by the fact that you can square root the number. So we're going to end up with two sets of brackets, an x here and an x here, which makes the x squared. Then a plus and a minus, doesn't matter which way around, or the square root of 16 is plus and minus 4. So then we just insert 4 here and 4 here, and this is your solution, or the factored solution, I should say. Okay, recurring decimals, x equals 0.045 recurring. Prove algebraically that x can be written as 1 over 22. So first thing I would recommend doing is writing x equals 0.045, and then this would obviously go 4, 5, 4, 5, and so on. That's so you just get an idea. Now, our main objective is to get rid of the 0.45. So what I'm going to do here is see what I need to multiply this by. So if I multiply this by 10, I'm here. By 100, I'm here. And by 1,000, I'm here. So if I multiply by 1,000, I end up with 1,000x equals 45.45. And then, like I just mentioned, this would go on and on and on. I'm just going to remove that just to make it a bit clearer. So I want to keep this part, but I need to get rid of this. So I can't do 1000x and then take away x, because x is not the appropriate one to take off. So I need to be able to take off 0.45. So if I know that x equals 0.045, okay, I need to make it this 0.45 recurring. So if I look here, I need to times it by 10. That means if I write 10x equals 0.45, I can then use this here and write 10x equals 0.45. I can then do take away. So if I do 1000x take away 10x, that's going to give me 990x. Oh, sorry. 990x equals 45. Then I can write x equals 45 over 990. Seeing as we're given the answer as 1 over 22, that means that it must be 45 must fit into 990. So what we can do is write x equals 1 over, and then we can see how many times the 45 would go in 990. So I'm not going to do that now just to save time, but 45 goes into 990 22 times, which means we have proven that it can be written as that. Obviously, all you'd need to do in the exam is just carry on with this 45 and then just keep adding, or however you would do it to get to the point. Okay, question 11. V squared equals u squared plus 2as. Find the value of s when u equals minus 4, v equals 5, and a equals 10. So what I would do first is I would rearrange. So the easy bit is putting the numbers in, but let's not do the easy bit first. Let's sort this equation out so we can get it for s. So that means we need to get it for s equals. So we've got v squared equals u squared plus 2as. I need to get s, so I need to get rid of everything else. What I can do, take away the u squared, so I end up with v squared minus u squared equals 2as. I still need s to remain. So then I can divide by 2a, so then I end up with v squared minus u squared over 2a equals s. This is the equation that I need to use. So then carefully substituting the values in, we've got v squared, which is 5 squared, minus u squared, which is minus 4, and then we've got over 2 times a, and that equals s. So if we do this calculation, we end up with 25 minus 4 squared is 16, so that would be 16 over 20 equals s. So then we can do 25 take away 16, which is 9, so therefore we have 9 over 20 equals s. For part B, make g the subject of the formula, so we have f equals g over g plus 1. So the first thing we need to do before we can think about moving anything is to get rid of this square root. So the inverse of that would be to square it. So if we square both sides, that's going to make this side f squared, and that would cancel out this square root. So we're going to end up with g over g plus 1. Now we need g the subject of the formula, so we need to do a bit of manipulation to get g's onto both the same side. Now they are currently on the same side, but there is this plus 1 here that we need to get rid of. So what I'm going to do is I'm going to times the bottom up to the f squared. So we're going to end up with g plus 1 and then the f squared in front of it equals g. Now to get this g out of the plus 1, we need to expand. So I'm going to end up with f squared g plus f squared equals g. Now I can write f squared equals g minus f squared g. And now you can see I've got the two g's on the right, but I still need to get them by themselves. So what I can do to do that is f squared equals factor a g out. That would then become 1 minus f squared, and now I've isolated the g. So if I then write this up here again, 1 minus f squared. To get g by itself, well, currently this is being times by g, so the inverse of that would be to divide. So I can, because it's in brackets, move the entire thing. So I end up with f squared over 1 minus f squared equals g. Okay, question 12. F is inversely proportional to d. So if we remember, we write f like so. So that would be f is proportional to d. To make it inversely proportional, we're going to do 1 over d. So if it's an inversely proportion, it's 1 over whatever the letter is. So in this case it's d, so it's f inversely proportional to 1 over d. We then need to remember we need to find k. So we have f equals k times 1 over d. And just to tidy things up, we can do the multiplication of the fraction. So we end up with f equals k over d. Okay, so of course we need to find k. We are given the values of d and f. So now I've got f equals k over d. To find k, I'll get it by itself. Currently it's being divided by d, so I need to times. So I'm going to have fd equals k, and then we are given f is 64, d is 20, and that equals k. Well, we've got 64 times 2, which is 128, and let's not forget the 0. So k is 1280. So it does say find a formula for f in terms of d. Therefore, we would write, using what we establish here, we would then write f equals 1280 over d. And this would be our final answer. Part B says sketch the graph of f against d for positive values of d. So we've got f is inversely proportional. Okay, we need to remember what that means. So that means as one increases, the other will decrease. So let's say we've got d along the x-axis here. As this increases, the value of f will decrease. So we'd end up with a graph that would look something like this. Okay, so if we imagine the value 1 here, for example, and the value 100 here, as d increases, the value of f would be decreasing. So really this line here looks a bit like it's stayed the same. Let me just draw this like so. Okay, question 13 is asking us to simplify. So we've got root 3 times these two terms in the bracket. So we end up with 2 root 3, or I should write root 3 times 2 root 3 plus root 3 times 1 over root 3. So what I end up with is 2 root 9 plus root 3 over root 3. So I can then of course simplify that. So 2 root 9, well the root of 9 is 3, so that ends up becoming 2, 3 plus, well root 3 over 3, that's how many root 3's going to root 3, well that's 1. So what I'm going to end up with is 6 plus 1, and I therefore get an answer of 7. Part B is saying rationalise the denominator of 15 over 5 minus root 7. So if you remember from rationalising, we have to have 5 minus root 7, okay, and then we times by 5 plus root 7 over 5 plus root 7. So therefore we get 75 plus 15 root 7 for the numerator, and then we end up with this 5 minus root 7 and 5 plus root 7. So I'm just going to take this expansion here and fold this out. So we end up with 25 for the first. The outside we end up with plus 5 root 7. Then we have minus 5 root 7 minus root 49. So if we simplify that, we got 25, well, plus 5 root 7, take away 5 root 7, well, that just has gone, minus root 49, and minus the root of 49 is, of course, 7. So we end up with 25, take away 7. That gives us 18. So if I then rewrite that again now, we got 75 plus 15 root 7 over 18. I then look and see if I can simplify this in any way, shape or form. It looks like I can divide this by 3. So I end up with 25 plus 3 root 7 over 6 as my final answer. For question 14, simplify fully 3e to the power 0. Well, anything to the power 0 is going to give you an answer of 1. Part B, simplify fully 64x to the power 6 over 25y squared, all to the power of minus half. Well, I want to make this a positive half in the C instead of a negative, so what I can do is flip this. So I end up with 25y squared over 64x to the 6, and this would still be to the power of half. Now with indices, I know to the power half means a square root, okay, or I could simply times these out. So what I could do is write 25 to the half times y squared times a half over 64 to the half times x6 times 1/2. So if I then did that, 25 to the half would then translate into being 5. And then we have the y squared times a half. Well, that would give me 1y. So that would be times y to the 1. And just to show you quickly, that would be 2 over 1 times 1 over 2, which would give you 2 over 2. And 2 into 2 is 1. Hence where that comes from. So 5 times y over square root of 64 being 8. So we have 8. And then same thing going on here with the fractions. We'd have x to the 6, so 6 times a half. Well, that's 6 over 1, so you'd end up with 6 over 2, which means we'd have to the power 3. Therefore, it would be x to the power 3. And this would be your final answer. Okay, so for the next one, write 5 over x minus 3 minus 4 over x plus 3 as a single fraction in its simplest form. So what I want to do is I want to make both denominators the same. So that's going to be x minus 3, x plus 3. x minus 3, x plus 3. Next thing I need to do is look at what the fraction actually has. So this one has an x minus 3, so I'm going to write the number 5, and instead of being the x minus 3, I'm going to do the opposite. So this is going to be 5 times x plus 3. Okay, I'm going to do the same here. This is going to end up being 4, and then it's going to be x minus 3. So once I've done that, I can then multiply out, so I end up with 5x plus 15. Take away 4x minus 12. And of course these would both be over these fractions. So x minus 3, or these brackets rather, and x plus 3 over x minus 3, x plus 3. So I can then simplify that by collecting like terms. 5x take away 4x would leave you with 1x. And then 15 minus minus 12 would of course be add. So 15 add 12 would be plus 27. And then that would all be over the same fraction. So we'd have x minus 3, x plus 3. And that would be the simplest single fraction. Okay, question 15. Diagram shows a straight line L1. Line L2 is parallel to L1. So straight away that means, I think we've done this question on a previous paper, but this means same gradient. Okay, and it passes through the point 2, 1. So we need to find the equation of L2. Give your answer in the form y equals mx plus c. So let's focus on line L1 for now. So what do we know about line L1? Well, at the moment we know that it intersects at plus 6 from here. So if we know our y equals mx plus c, we know that c is plus 6, so we've got y equals mx plus 6. So we need to find the gradient. So to find the gradient, we can do a triangle. So we've got a distance of 8 and a height of 6. So we know that m equals y over x. So therefore we have a distance of 6 for the y and distance of 8 for the x. So if we then simplify that, we end up getting 3 over 4 for our gradient. Now looking at that, 3 over 4, if we've got a positive gradient, don't forget, that would mean it's going uphill if you're starting from the bottom left. This line, of course, is going negative. So we can look at this as going from 6 to 0. So this should in fact be a negative 6. So if we then put that in, we end up with negative 3 over 4 for our gradient. So then we end up having, for L1, y equals minus 3 over 4 x plus 6. So it does say that line L2 is parallel. So L2 is parallel. Therefore the gradient would be exactly the same. So we could write therefore m equals negative 3 over 4. We have y equals mx plus c. So we can fill that in as y equals negative 3 over 4 x plus c. Now we are told that L2 passes through this point here, and we can use these values now to find out our plus c. So we've got a value, obviously this being x and this being y. We can substitute that in here. So we've got y as 1 equals minus 3 over 4, our value for x, which is 2, plus c. That's what we're trying to find out, so we can't substitute anything. Then we have 1 equals minus 3 over 4 times 2. Well, that we could treat as a fraction, so 2 over 1. So we're going to end up with negative 6 over 4 plus c. So moving this up here, we'll have 1 equals negative 3 over 2 plus c. And therefore we'd have 1 plus 3 over 2 equals c. Remembering our fractions, this would be over 1. We need to get denominator the same base, so we're going to have that as 2. So that's stays the same as 3, and this would change to 2. So 2 plus 3 would give us 5, so we'd have 5 over 2 equals c. So now if we add all of this into our equation, which is y equals mx plus c, we found m early on, which is y equals negative 3 over 4 x, and we just found our plus c, which is plus 5 over 2, or you can write this as y equals negative 3 over 4 x plus 2.5, because 5 divided by 2 is 2.5. So this question is all about using what you're given and observing the values that you see on the graph. So you can again do it visually, or you could have done the gradient via m equals y2 minus y1 over x2 minus x1 if you preferred. You would have got the same answer. Just be very careful and make sure you make this observation about a gradient. So positive would be going uphill, and a negative one would be downhill. Okay, so with this question, line L3 is perpendicular to L1. So let me just get the information from L1. So we know that L1, the equation of the line is y equals minus 3 over 4x plus 6. So it says it's perpendicular. So when it's perpendicular, we multiply it by its negative reciprocal, which basically just means if we know that the gradient m is minus 3 over 4, we now make it 4 over 3 and times by a negative, so it ends up becoming a plus in this case. So for L3, we know that the gradient is 4 over 3. Now it says here that it passes through the point 0 minus 5, so therefore we have y equals mx plus c. We now know that y equals 4/3 x plus c, and again we're given the points where it crosses. So if we fill those in, we end up having minus 5 equals 4/3, where x is 0, plus c. Therefore we end up having minus 5 equals c, or c is negative 5. So therefore we have y equals mx plus c, y equals 4/3 x minus 5 as our answer. It does say it would like it in this form, ax plus by plus c, so we just need to do a bit of rearranging here, and then just shift the y over, so we end up with 0 equals 4/3 x minus 5 minus y, and it does mention that they need to be in integers, so to get rid of this divide by 3 we can times by it, so we end up with 0 equals 12x minus 15 minus 3y, and therefore to arrange in ax plus by plus c, we end up with 12x minus 3y minus 15 equals 0. Okay, and we did that to get rid of the fraction, because it mentions up here that they need to be in integers. Okay, question 16. We've got a solid shape here made from a cylinder and a hemisphere. So the radius of the cylinder is equal to the radius of the hemisphere. So what we can do is we can find the radius using potentially this formula here. So let's just carry on reading. The cylinder has a height of 10 centimeters. The curved surface area of the hemisphere is 32 pi centimeters squared. Work out the total surface area of the solid shape. Give your answer in terms of pi. Right, so it says here the radius of the cylinder is equal to the radius of the hemisphere. So if we know that the surface area of the hemisphere is 32 pi, let's try using this formula here. So we know that the surface area equals 4 pi r squared. Well, that's for a sphere. We've got a hemisphere, so we need to divide this by 2. So if we divide this by 2, we end up getting surface area equals 2 pi r squared. Now we know that the surface area is 32 pi, so we can write 32 pi equals 2 pi r squared. Then we need to get r by itself, so we can do 32 pi divided by 2 pi, equals r squared, and therefore we would end up having pi cancelling with the pi, and then 32 divided by 2 would give us 16. So 16 equals r squared, and obviously the square root of 16 would give us 4. So from that we now know that the radius is 4. So what I need to find out now is the surface area of the cylinder. So we know that it's got a height of 10, but I do not know what the circumference of that is. So what I'm going to do is I'm going to just show this. So what I'm going to do is unwrap this to basically give me a rectangle. Okay, so I know the height is 10, and I need to find what this is. Now this part here is the circumference of the circle. So the circumference of the circle is 2 pi r, so that's going to be 2 pi times 4, so it's going to be 8 pi. So in order for me to find the area of this, I'm going to do 8 pi times 10, which is going to give me 80 pi. So at the moment I've got the area, surface area for the hemisphere, so this entire top section. I've got the surface area for the outer section of the cylinder, but what I don't have is the surface area for the bottom circle here. So let's not forget that, because it's quite easy to forget. Well, we know the area of a circle is pi r squared, so pi times 4 squared, that's going to give us 16 pi. Now I have my 3 measurements, so I can do 80 pi plus 32 pi plus 16 pi, and adding those all up, so 80, 32 and 16, I'm going to get 8, 9, 10, 11, 12, 128 pi as my final answer, because it does say leave in terms of pi. Okay, question 17. There are n sweets in the bag. 6 of the sweets are orange. So if there are n sweets in the bag, first thing that I'm thinking of is that means that the denominator is n, because that is what the sweets would be out of. 6 of the sweets are orange, the rest are yellow. So if we have a probability tree, because I can see that it says she takes a sweet at random from the bag, she then takes another sweet. So let's do our 2. So we've got orange and yellow. So if we look here, what are the chances? So 6 of the sweets are orange, so that means we're going to have 6 out of how many we don't know, so that's why it's n. So here we're going to have 6 over n. The rest of the sweets are yellow, so we're going to have the total number of sweets, which is n, which is what we don't know, take away the 6 that are orange, so that's n over 6, and of course it's all going to be out of n. So there are our 2 probabilities for our first selection. Now of course this is going to go into orange and yellow again, and orange and yellow again, because it does say it's taken twice. Now it does say that Hannah eats the sweet, so that means it's going to be taken out, so we're not going to see it again. So for orange this time, well, this is going to go to 5, and our denominator is going to go to the n that it once was, take away the 1 that she's eaten. Now if we do the same thing for yellow, we know it's n minus 6, because yellow hasn't been taken, and this is going to be n minus 1, because 1 sweet has been taken. If we then fill in the bottom section, so if 1 yellow is taken, well, that's going to be the n that it was, minus 7 now, because it's take away 1, over n minus 1, because 1 has been taken, and the orange would stay as 6, so that would be 6 over n minus 1. Now it does say that the probability that Hannah eats 2 orange sweets is 1/3, so that would be this one here, so orange, orange. So if we remember from a probability tree, we're going across, we multiply, and when we're going down, we add. So we've got 6 over n times 5 over n minus 1, and according to this, that equals 1/3. So if we now multiply, we end up having 30 over n squared minus n equals 1 over 3. So what we can do is then multiply the 3, so we end up with 3 times 30 over n squared minus n equals 1. So we end up with 90 over n squared minus n equals 1. We can then get the n squared minus n to the top by timesing by it, so we end up with 90 equals n squared minus n. Now the 1 hasn't disappeared, but what we've done is 1 times n squared minus n, and because it's 1 then it essentially disappears, but it doesn't completely disappear. Then we end up with 90 equals n squared minus m. Now it does say here that show that n squared minus n minus 90 equals 0. So if I put a 0 here, I can do n squared minus n minus 90, and of course that's the same as n squared minus n minus 90 here. So there is the show that section complete. Now it says here B, so let's say for example you didn't manage to do that in the exam. Part B says solve n squared minus n minus 90 to find the value of n. So solve, well, it's a quadratic. We must remember the technique, a times c. So this is a 1, so 1 times c is 90, and then list the factors to give you the center number. So we can do 1 times 90, of course, 2 times 45, and then we can keep going. So I think 9 times 10 will quickly give us our answer of 1. So then I'm going to split this up into n squared minus 10n plus 9n minus 90. And what this will do, minus 10n plus 9, that will give our minus 1n. So then we draw a line and factor. So n squared minus 10n, we can take out the n, then we end up with n minus 10. We then copy this across, so we get n minus 10, and then we find the number to put here that will give us 9n minus 90. Well, that will be plus 9. And then we can just test that quickly. 9 times n gives us 9n. 9 times minus 10 will give us minus 90. Once we've done that, we can then write n plus 9 in brackets and n minus 10 in brackets. So to get a solution, we write n plus 9 equals 0 and n minus 10 equals 0. Therefore, we have n equals minus 9 and n equals 10 as two possible solutions. Now, if you remember what n is, at the very top, n is the number of sweets in a bag. Well, we can't have a negative amount, can we? So therefore, our answer is n equals 10. So there are 10 sweets in the bag. Okay, so question 18, we have the sketch of the curve y equals sine x. Write down the coordinates of point P. So we know it says that it's a sketch of the curve y equals sine x, so it's a normal sine x curve. We know it goes from 0 to 360. So point P is dead on halfway, so therefore our coordinate is going to be 180, 0. Now if I look at part B, it says write down the coordinates of point Q. Well, if 180 is here and 360 is here, the other value is 270, so that would be 270, negative 1. Okay, so it goes up to positive 1 and negative 1. Okay, so here's a sketch of the curve y equals a cos b x plus c, and from 0 to 360, find the values of a, b, and c. So what I want to start off with is we know a standard cos graph, or cos x graph. Okay, now we know that a cos of 0 is 1, then 90 is 0, we then have 180 at negative 1, 270, and then 360. So if I just join that up, this is a standard cosine graph. Okay. So the A part is responsible for the amplitude. So the amplitude is the distance between a 0 and the 1. So a normal cosine graph is just, of course, cos x, so that would be an imaginary 1 here. Now, what's very easy to think initially is that the amplitude, okay, so if that's 1, then A must be 3. Well, we need to work out the halfway point, because as you can see here, from a standard one, we've got 1, from 0 to 1 is 1, and then we've got 0 to negative 1. But if we take a look at the cosine graph that's drawn for us, if we find our halfway point, okay, it's more like we've got a total peak of from 3 to -1, so that's a gap of 4. So our halfway is 2 away. So our halfway point is actually on the number 1. That means that the A is not 3, it's actually 2. Okay, because you have to look at from the center point how much it goes up from the center point and down. Okay, so that's answer of 2. Okay, and B will be responsible for the number of cycles. So if we look here, we can see that there is 1 cycle, 2 cycles, and 3 cycles. So this value right here would be 3. And part C is responsible for the shift. So I've got this horizontal line here. So normally a cosine graph would be on 0, or at least the halfway point. This has been shifted quite clearly at +1. So therefore our value for C would be +1. Okay, and that is the end of that question for a total of 3 marks.